Welcome, viewers, to another episode of the It Depends podcast, where we get to talk to people who are doing amazing stuff in the data analytics and AI space. They're using cutting edge technologies, and the companies are uh, being recognized for the work they do. As a result, I am thrilled today to host Fei Meng from Nuro. Yes, that Nuro, the company that is putting self-driving electric vehicles and robotics on our streets. Fei leads a fast-growing data platform team. Spoiler alert, he's hiring. Is that correct, Fei?
Yeah, we're hiring.
Okay, I saw that on your LinkedIn. So we are going to dive into what does it actually take to build a data platform that is capable of supporting fleets of autonomous robots. To me, this is where generative AI is heading next. This is where generative AI meets the real world, and that's robotics. In fact, the company's name, Nuro, which is spelled Nuro, is actually an amalgamation of new robotics from the founders. So, with that, without stealing any more thunder, Faye, so great to have you on this episode. Thank you for joining.
Thank you, Sanjay. Yeah, I'm happy to be here to share what we've learned in the past years on autonomous driving. Yeah, glad to be here.
So I would love to get an introduction to what is Neuro and what is your role. One thing that, since I mentioned I was checking LinkedIn and seeing what news, I was quite amused to see that 2 weeks ago, Neuro teamed up with Uber and Lucid Motors to develop a next generation global robotaxi program. And then it went on to say with L4 driverless technology. Help us unpack what I just said in common person's terminology, and then please educate us on what your role is.
Yeah, of course. Yeah, happy to share, what the company is working. Over the years, we've been working on a few different product or projects. And about over a year ago, we pitched into this tech licensing strategy of the company. So over the past years, we've been developing L4 driverless technology. We initially started on delivery robots. You have probably seen some of those robots in California, Arizona, and Texas. As I said, a little over a year ago, we pitched into this tech licensing strategy where we work on the what we call Nuro Driver
Hmm.
together with partners like OEMs and mobility service providers. We announced that partnership with Uber and Lucid Motors a month ago. That's how we will continue to collaborate with the partners to deliver level 4 driverless technology. And the first application on Uber's network is targeting a 20,000 plus vehicle robotaxi program. So we want to bring what we are great at, which is the technology we've been developing, to the network service provider, and the users can benefit and use the technology we're developing.
Is this technology also in non-driverless vehicle, autonomous vehicle? Like, is it in like humanoid robots? I was at a AI conference in Beijing about 2 weeks ago, and there were humanoid AI robots everywhere. So, is that technology different from what you have?
Great question. When we started the company, the mandate or slogan of the company is to develop all the different types of application of robotics.
Hmm.
Humanoid is one form of the robotics, which is probably years down. We started from delivery robot. We start to work on robotaxi now. So those every of those this robotics application is one form of applying the technology. In terms of
Got it.
tech stack, they are different. They also share a lot of the similar components in the system. And as the technology evolves, a lot of those components become more and more similar. So humanoid isn't something we're working on now.
Okay.
It's probably something we'll look into in the future with what this company is designed for.
And your founders came from Waymo, right? That's their
Yeah,
pedigree is in this driverless. technology?
Yeah, background on that, Dave and Jay-Z were both the very early Waymo
I
engineers.
see.
Back then, it's part of the Google X project. They joined Waymo in, I believe, 2008 in the very early team. They left Waymo in 2016, right before it's rebranded to Waymo from Google X. So
Got it.
they were the early engineers in the team. They started this company to build something different
Yeah.
from the original plan. Yeah.
So Faye, I want to get into the data side of things because you're the head of data platform. What does it take to build a system like that from data analytics AI point of view? What are some of the data related challenges that you had to keep in mind when you designed your architecture?
Mhm. So when we say data platform here at the autonomous driving space, it is a bit different from what most people refer as a data platform.
Got it.
We are the team responsible for the entire flywheel of the data in the application. So we are dealing mostly end to end
Hmm.
from the very upstream data acquisition, uh, data storage, data mining, evaluation, and routing back to data. So we are responsible for the entire lifetime of how we use data to develop, eval, and validate the product. So it's slightly different from more traditional understanding of data platform where you have data warehouses, lake houses, you run analytics and you run evals. So it's a bit different, but yeah, it kind of share the same principles of developing a data system. With that, yeah, a lot of the common building blocks still hold, but we developed something new. If I look back from 2017, there wasn't any mature system to support this type of workload. So we develop a lot of those customized in-house components in the system. But over the years, with the changes in the industry, there's a lot of more components available for us to use. So gradually we moved some of our stack into this new system. Yeah, back to your question, how do we deal with the unique challenges in self-driving? Um, if you look at what people are doing right now in large language model, VLMs, a lot of the challenges that they are seeing now are something we've been dealing with for years or even a decade. And I'm glad all this new technologies start to be available and we start to adopt that. That's also like how we picked AlloyDB in last year in our
Okay,
ecosystem.
so I want to get to data storage. I'm trying to build out the story. If I take a driverless car like Waymo, for example, that's the one I know. But let's say I take one with your technology, driverless technology, L4 driverless technology in a 30-minute ride, how much data is being generated? Is it like sensor data? Is it like IoT kind of data? What is it? And then, because you said you do data acquisition, data storage, so, and you mentioned you store it in AlloyDB in Google Cloud. But before like, how is the acquisition being done and what kind of data is it? What format is it in?
Great question. You largely can think the autonomous driving vehicle is the IoT device. It's the same setup. You have
Correct.
a device operating in the wild in the physical world.
Hmm.
It has multiple sensors attached to it. It
Hmm.
will collect the sensor data. It will run some functionality on the device. Then it will send things back. What's different between a typical IoT with the autonomous driving vehicle is the magnitude of everything. You have a much powerful compute on the vehicle compared to a typical IoT device.
Can you
You
quantify?
may,
Can you
yeah,
quantify?
if you look, yeah, let's just use a public example. If you see the Waymo vehicles driving around,
Right.
you can easily see there's multiple
Hmm.
dozens of sensors attached to it. It's multiple tons of weight operated in the public environment.
Hmm.
Uh, there's some public knowledge of how much computing power is built into the vehicle, how much power is consumed, how much storage is used. So it's just a few magnitude higher than a typical IoT device. But if you're familiar with a typical IoT device, it shares the same architecture.
Hmm.
It's just tens or hundreds of more resources available to these vehicles.
Do you have an idea how much, what amount of data is generated in a typical ride? Because I'm trying to extrapolate into how
Mhm.
did you size up and choose AlloyDB? Because I'm assuming, as because you are launching the global robotaxi. So if one car has X amount of data and you multiply it by number of cars, number of cities, that's a lot of data. So what scale are we talking about here?
Yeah. Uh, so they're the two folds. On the data, the vehicle generates every second, every minute, every hour.
Hmm.
It's a lot. It's definitely to the magnitude. Depending on how you configure your sensors, if you retain the entire sensor data, you can
Hmm.
calculate how much data is needed. For example, each camera, if you operate the camera at 8 megapixel, and if it's 36 FPS or 60 FPS, you can calculate how much data has been generated just from one sensor. If you multiply that by, say, 30 cameras from the Waymo Gen 5 vehicle, you carry a lot of the data. And this applies to LiDAR data, applies to radar and other sensors. So just the amount of data the system can generate real time on the vehicle is massive. There's techniques to reduce that load. You don't probably need to store all of it. You
Hmm.
can probably compress it. You can also deduplicate some of those. So that will just bring the data down. But in terms of magnitude, yeah, a simple math on the sensors can yield hundreds of gigabyte or terabyte of data per hour, just based on the sensor config.
So
So that's
hypothetically,
sort of the first layer of how the data is generated from the vehicle.
so this autonomous vehicle is driving down Market Street in San Francisco. All this data is being generated. How does that data make it into AlloyDB?
So that can part. First of all, it's not making to the cloud databases. For most of the L4 driverless deployment,
Hmm.
the vehicle is supposed to operate without the network connection. So it has to do it
Hmm.
on its own in
Hmm.
case there are some outages of the
Yep.
network
It
provider.
goes
So you
through a
cannot really,
tunnel. Yeah.
yeah, you cannot rule that out. So the vehicle has to operate itself safely, at least
Hmm.
in a certain amount of time that's partially defined by the alpha requirement. And the vehicle probably can maneuver itself to a safe spot if it deems to be unsafe after that allowance of the driving distance. On the database side, we use LODB to store the metadata, not the raw data of the vehicle. Like
I
we
see.
are not storing sensor data into a Postgres database. The benefit or the value of the Postgres database is really on the transactional part, analytical part of analyzing data, mostly in the structure space. For the majority of the data, we're not storing in that database. We have a separate, blob storage and Google Cloud storage. We leverage some other techniques, but if you look at the entire uh, data architecture setup, none of those is making sort of in real time to that database.
So,
Even if there is some tiny pieces, it's not
yeah.
critical.
So the raw data is going to Google Cloud Storage, and then the metadata is going into AlloyDB. Is that correct?
Uh, yes, it's not in real time, but yeah, eventually the different part of the data will make into different part of the storage ecosystem in the cloud. We've heavily on Google Cloud and Google Cloud Storage, and the various types of databases are where eventually the data is located.
What kind of AI is it like these cars, driverless cars, do they have an LLM in the car to make some decisions? Or in your architecture, do you have AI generated workloads or AI workloads?
Uh, Great question. The LLM VLMs are new to the industry.
Hmm.
If you asked me this 2 years ago, I think most people say no, like we
Yeah,
can't, we won't.
yeah.
In the past 2 years, yeah, there's a significant progress made from the large language model space, and there's adopting new modality to the models. Now it can ingest not just text, it can also use images and videos and other form of data. So the industry start to look at how this type of new model can help in driving. There's some preliminary research done from both academia and also industry.
Hmm.
There's published papers from different part of the world about leveraging LLM or VLM to drive. And actually, a lot of people start to talk about how they can leverage VLA to drive in the Chinese community in autonomous driving. So it's gradually making into mainstream. Some of them have been landed in production more in the L2 ADAS space instead of the L4 space because of the high sort of requirement on reliability and safety. Um, there's publications on that. We've done a experiment, what we call Lambda, in our stack,
Hmm.
where it runs on board. You can ask questions to the model, and model explain what it does. So it's a LLM based part of the stack we experimented with. We kind of showcase that to our customers, and people are excited about that. There's still a lot of work going around on that. But that's what we are leveraging. We're exploring different options of leveraging the language part of the model to help driving.
Mhm.
But again, yeah, there are a lot of explorations in the industry in the space about leveraging that. And if you step back, when you see driving, it is literally just driving a trajectory for the vehicle to follow. So that itself can be abstracted as a generative question, and any generative model can help on that if they can generate a safe trajectory of the vehicle.
Got it. I want to ask you about AlloyDB scan. So they have a state-of-the-art vector indexing and vector on top of vector embeddings. But before I even go deep into the trench and talk to you about scan and what was the environment at Nuro when you joined the company, and did you migrate from what used to be there to AlloyDB, Google Cloud overall? So just can you share some of the history of how you ended up with Google Cloud?
Yeah, when I joined Nuro, the company's stack is already mostly in Google Cloud. Google Cloud has been the primary cloud provider for Nuro's technology, which
Mhm.
I think is working very well for the state of the company,
Hmm.
the support we need. So we've been using or leveraging Google Cloud's offering, include compute, storage, databases, for a very long time. We're heavily relying on Google Cloud's scalability, safety, redundancy to help us scale. So when I joined Nuro, it was already mostly on Google Cloud. We have different types of databases we used.
Mhm.
What's nice about cloud is you have access to basically everything with a fraction of the cost if you operate your own data center. I worked in environments where we need to work closely with the infrastructure team to spin up any instances you need in the database world. You need to manage all the resources. There's usually a very large infrastructure team providing all the access you can just easily
Like
get from
self-managed,
cloud. Yeah,
yeah,
you need to
self-managed
write.
IaaS
Uh,
database. Okay,
it's very different. So
got it.
at Nuro, we use any databases Google Cloud provides, and over the years they keep releasing new features, products.
Mhm.
We picked AlloyDB in the time that we're consolidating our transactional, some analytical workloads in the database. We were using the databases from Google Cloud already, and we were evaluating the options to uh, scale the databases with higher throughput, lower latency, more availability in transaction analytical space. And also, we were at a point we were picking a right vector database.
Hmm.
Um, Google Cloud released AlloyDB. It's pretty early back then. It was like pre-GA, and we picked that. and we have a pretty close collaboration with the GCP team. So we start to explore this idea whether we can, really leverage this new offering, and that's how things started.
Did you have a separate vector database, a standalone? Because there's so many of them before
We
you migrated.
we we did. So we have really the philosophy of the company is we want to move fast, want to get all the resources, infrastructure needed to support our business. So we usually pick something to bootstrap the process, the product. We did have separate vector databases um, back then, and we were looking for scaling. We were expecting to add way more vectors in the databases. We're looking for solutions to provide better performance of similarity search and things like those.
What
Yes.
what vector capabilities do you use in AlloyDB? Like when you are storing vector embeddings. So let
Mhm.
me ask, where are these vector embeddings coming from? In a Waymo or other every driverless car, there are all these cameras. Are those images that are captured in the car? It's in a batch manner. Uh, Entity go through some sort of embedding model, and then that makes it into AlloyDB. And then what kind of queries do you do?
Yeah, so as I said, the data acquisition or collection is done by the vehicle. We
Hmm.
do offload them into the cloud after the operation. And we also work with third-party providers to get the data into our infrastructure. From there, we run batches of post-processing on the vehicle data.
Mhm.
We can run all sorts of different models, including our own model or
Hmm.
some third-party off-the-shelf models to run any inferences as we want. We can generate embeddings in any ways we want to combine. So it could come from our own model, it could come from the off-the-shelf models. So we combine all those technologies together to generate the right amount of or layers of embeddings we are interested, and we store them into a database. In our case, it's the AlloyDB
I see.
database.
Got it. Can you give an example of what use case? What are the use of what why you're doing these queries? Like for example, if you were in retail, and you're a product catalog, and you're pictures of shoes and clothes and ski gear, you can embed it, store the embeddings, and then do some sort of a hybrid search.
Mhm.
I'm going to Colorado for a ski trip. Show me this. So it's a natural language hybrid search. In your case, what would that example be?
That could be one of the examples we're providing. Actually, that's something we also offer to our customers,
Hmm.
which are or who are the autonomy and system engineers in our setup. So we, as we discussed, have sensors, so many types of sensors. We do have images in the sensor setup. We do have other sensors as well. We can generate embeddings to represent that world, and we can connect that to the text base as well. So people can write a query to find what they want. They can describe what they want, and we'll run the searches for them and identify those driving scenarios for the users. You can find some pretty, I would say, crazy scenarios where it's really hard to model in traditional indexing mining approaches. With the capability of the models, it could become pretty easy. So we offer a suite of applications for our customers. They can mine the data they want, and we keep improving the performance, precision, recall of those tools for them.
A lot of analytics happens on these columnar, like BigQuery or other data warehouses that are optimized for running high throughput queries. So in your case, you're doing data acquisition and you're storing it, embedding it, storing it in AlloyDB. You give your customers access to that data. What do they use? Are they, or what do you use for analytics?
Yeah, so for first of all, yeah, we use AlloyDB as one of the vector database. We do have other vector databases as well. AlloyDB, as you know, is more a real-time database, so
Mhm.
they can be serving the real-time application.
True.
So we'll put a bunch of applications on top of the AlloyDB, so people can go to the tool and search something. They can get the responses pretty quickly. So fast iteration of the data mining. They can
Mhm.
quickly tweak what they want, do some experiments. We also have some more batchy setup of the vector, so you can run a query over a larger corpus. You don't need to respond instantly. Then you can wait for that to come back. That's the vector side of infrastructure we have in our house.
I got it. When you started using AlloyDB and its features, some of the newer ones, did you have to go through a data migration?
Uh, we did some migration, yes. Uh, for a different part of the stack,
Mhm.
it's different. For the Postgres compatible part, it's pretty easy. Um, it's migration, but GCP Pro Google Cloud provide this tool for sort of a one-click migration. It's Postgres compatible. You connect that to the instance, and the GCP is dealing with everything for the migration. So once that's done, the database is available. To us, it's really painless. We didn't really get any sort of downtime from that part of the migration. For the vector part, though, it's a bit different. Vector is still a pretty new feature in the offering of the database. When we migrate, it's even pre-GA. So we worked with the Google Cloud engineering team for the migration
Mhm.
from our old vector storage into the new storage. There's some hiccups in the process because of the pre-GA product. We work with them to solve all the different issues in the migration. Eventually, we move all our vector store into that. The nice part is, yeah, we kept the old instance running for on the old
Mhm.
database. Once it's finished, we cut over the traffic to the new database. And it's also not deterministic as transactional database. Your
Yeah,
results will be deterministically the same.
yeah,
In vector space, if you're doing similarity search, yeah, there isn't this 100% accuracy, right? You are
yes.
doing a best effort search. Yeah, kind of alluded to your question on scan. Uh, then yeah, the performance is decently well over that migration.
That's great. In fact, as I was asking you this question, I was literally fascinated by my own question, if I may say so, because I spent a big part of my life doing data migrations for structured data. And that is so well understood. And Google makes it even easier with one click and they take care. But how do you migrate vectors? Like if you have a vector database and now you're going to go to a consolidated database where vector is a data type, how do you migrate that? That is something which is very interesting because I'm thinking that the embeddings are different depending upon what embedding model you use to create those embeddings, right? So you have to make sure that you're using the same model on both the source and the destination. Otherwise, it'll create embeddings in totally different ways. So and then there's this question of accuracy. How do you define accuracy? Because it's not the definition of accuracy changes in unstructured data.
Okay, so on the first one, on the embedding generation, if you look at what the Gen AI world is doing for the embedding generation, there's um, pre-built workflow. You get some input. Some workflow can help you to generate embeddings,
Mhm.
or some database itself can help you to generate embeddings. But if you just pull out everything and look at what's happening behind the scene,
Hmm.
uh, something is running, some model inference is running on text, images, or some other format, and you will generate embedding, which is vector, like 16.0, 128.0, depending on how you set up the size of vector. In our case, we control everything. It's a nice part of working in autonomous driving. We control the entire stack. We
Hmm.
can customize, operate any part of it from how each bit is emitted to how it's managed. So in our case, it's pretty straightforward. We control the entire workflow to run inferences, generate embeddings, and we can point the embeddings to anywhere we want. So as long as we are adhering to the same workflow, the same setup, the vector will be the same, like formats, the setup
Got
will
it.
be the same, and we can write to any database storage as we want,
Yeah.
and we can make the cutoff anytime we want. And so there's
Hmm.
this writing path we're generating where it's pretty typical any storage. Like I used to work in hypervisors. When you do the VM migration, it's the same thing. Each VM is writing data constantly to the storage, and you will start to replicate the data to a separate hypervisor. Then once the data catch up, then you will do this instant, like live VM migration. So it's a storage problem eventually. You warm up the other hypervisor and you move everything over. Once you get all the consistency at microsecond level, you will switch the virtual machine. In our case, it's more or less the same. You write to a database, you start to do write to another database, and you do this catch up, and eventually you cut over to the new database. So, as I said in the very beginning of this podcast, a lot of the things we've learned from industry, storage, machine learning industry, machine learning infrastructure could be applied here. We're basically following the same pattern
Can you
here
share?
for the data migration. Mhm.
So, can you share quickly, just for the viewers, what are some lessons that you've learned so they know not to make the same mistakes?
Um, I mean, it's a pretty dynamic environment. Uh, it won't be surprised. Like I think what we learned is you have to go through some iterations for any of this workload. The earlier, the better. You can probably optimize your workload or setup to reduce maybe 1, 2 iterations, but you will probably go through several iterations. So
Like
the
evaluations. Evaluation is such a hugely critical task because, like you said, the answers will vary. So, how do you make sure that your responses are I don't know if you have to worry about ethics but hallucination. Uh, but how do you do that? How do you evaluate do you constantly monitor the output and then call out if you feel it's hallucinating?
For any machine learning workload, in our case, we have some evals we set up for uh, the services. So we
Hmm.
need to have a baseline of performance of the embedding based product. We'll have that set up. So we can run evals for old, new databases and try to use that as a baseline. There are differences between different databases for vectors. The scalability is very different. You can run or generate millions of vectors, or can also generate hundreds of millions of vectors. In that case, it's probably different because not all the databases can support that level of scalability. So that there will be differences on that. Just for the baseline, yeah, we do have some basic evals. For the larger, yeah, it's an ongoing learning process. You will do
Yeah.
something, run some evals, and meet some criteria, and make to the next phase of the adoption.
So you said your customers can they run queries on top of the data set. Is there are there agents that you have built that you are providing, or are these SQL queries? How is the data being analyzed?
Yeah. Again, as I said, we develop most of the stuff from scratch
Yeah.
for our use cases.
Yep.
Uh,
Internally too. Yeah.
Agent is a recent concept. In my opinion, agent is a workflow plus data access
Hmm.
with the help of the LLM. We developed some of those workflows. It predates the agent concept. If you think about what it does, it's kind of an agent now. So I don't think that's like fundamentally something got changed in the agents world. A lot of those building blocks are the same as before. So we build all the agent or the building blocks for the workflow. Sometimes it's agent-like, sometimes more traditional application-like. there will be more and more pieces we added in that process to make the workflow easier, smarter, more intelligent. We have some separate workflow to integrate those workflows together.
Love it.
But yeah, we've been building that. We are adopting new um, what people call agentic workload into this space. That's again a fast evolving active area.
I see.
We're learning and developing.
So, Faye, we only have a few minutes left. I want to have you see if, based on what you are allowed to say, what's your future roadmap? Like, let's say AlloyDB, where do you see next, and what are you most excited about?
Scale is really a big
Mm,
part of the next. As the industry is evolving, having more data, you will have more data. You will have bigger
mm,
models. You'll have more access to the compute everywhere, and scale is going to be what everybody is solving. So in terms of what we have in mind, we need to scale. We need to get
mm.
help from the cloud provider. We need to get help from other vendors for all the resources we need. And that's what we're thinking. And in the infrastructure world, uh, scalability is always how you'll get to the next level. You'll scale your services, you'll scale your databases, you'll scale your workflows, you will scale your compute. So scalability is really the main. Um, it's not a problem yet. It's something we've been thinking and how we can strategically scale the infrastructure.
Amazing. Thank you so much, Faith. This has been fantastic. I really appreciate you came on to share your views. I learned a lot. It's not a space that I think about from day to day, but now that you shared all this, now next time I see a Wemo on the street, my mind will start like, wondering what's going on behind the scenes. So thank you so much.
Thank you, Sanjay. Thank you for having me here.
You're welcome. So till next time, everyone, thank you for staying on. See you. Bye.